Hi everyone, Alistair Spears here. I'm a Senior Director here in the Azure Business Group, focused on our global infrastructure business. Now, today we're here to talk about security, and you've probably heard about security in depth, but we're going to talk deep down in that depth security at our data center and hardware innovation layer as well. So let's begin. So when we think about the cloud infrastructure, let's take a step back and think about where is the cloud? What is the Microsoft cloud? And our global infrastructure is really a set of components, physical infrastructure and the connective network that ties all this infrastructure together. The physical component is made up of over 300 data centers worldwide, arranged into what we refer to as data center regions. Each of these regions is linked together by one of the largest interconnected networks on the planet. With the connectivity across the globe, these Azure data centers can provide high availability, low latency, scalability, and also the latest advancements in cloud infrastructure, everything from AI, high-performance computing, cloud-native workloads, and software as a service capabilities as well. And so this is the platform when we talk about Microsoft's global infrastructure that's powering not just Microsoft Azure, but Microsoft 365, our Office 365 suite of products, our business apps, Bing, Xbox, and all these capabilities run on this global network. And of course, it's expanding and it's constantly growing as we find more and more new and interesting use cases in this cloud. Over the past year, we've expanded our data center regions and our AI capacity in Japan, Mexico, Spain, Wisconsin, et cetera, et cetera. So the size and scope of this infrastructure that we're building is kind of truly staggering. But of course, all of this is built on enterprise-grade capabilities. That's our bread and butter at Microsoft. And so building in this security capability is really critical across that platform. And I'm not going to go too deep into these parts, and we'll get back to the hardware and the data center infrastructure, but a couple of important enterprise-grade product features and product processes that we have in place in Azure, which is really important to understand. Firstly, we enforce multi-factor authentication across all Azure sign-ins to prevent fraud and fraudulent use of compromised credentials. Secondly, we have over 100 compliance certifications across this platform, including ones that are specific to countries, industries, and particular regions. And then on top of that, we're providing a set of guidance around compliance, around protocols like NIS2 and other capabilities that require some work on your part, as well as some work on our part to help make your organization compliant to these standards as well. So this mixture of products and processes is what makes up this cloud service that we're operating. But let's get back to data centers. So we talked about what data centers were, but let's look at kind of a picture. We've seen maps and diagrams. This is an example of one of the data center areas in our US West 2 data center region. That's located in Quincy, Washington, which is about 3 hours drive east of Seattle here, where I am right now. The interesting thing about this data center in this picture is you can kind of see just the scale and the scope of this infrastructure. Let me point out a couple of things that you may not notice just from this picture as well. Firstly, you see different buildings here and different designs. And so these data center regions are designed to expand over time, and they're constantly being built and constructed and upgraded and serviced. The second thing is that this is a secure facility. You see gates, guards, facilities, and protections built around the physical infrastructure to reduce the risk of unauthorized users gaining physical access to the data and the data center resources as well. Now, you'd expect all of the physical security capabilities to be here: guards, access approval, cameras, logging, auditing, and all that capability. But inside the data center, let's talk about that system as well. This secure hardware is really what's running in this data center. And so this secure hardware is not just a single layer of defense. It's not just the gates around these data centers, but it's built into every one of the servers that we operate in Azure through a series of security technologies at every layer of the stack. The most effective security architecture that we've found is when we have our software constructs and the software promises that are backed up by this secure, attestable hardware. And so that software and hardware co-design is what really brings this security investments to life and allows us to compose really stable, resilient systems. So let's talk about a couple of the unique things in this particular server that you see on the screen here. As we think about CPUs, at the CPU level, we're able to run confidential virtual machines and silicon-rooted trust. We have capabilities like Azure Boost, secure host management interfaces, a security control manager card, and finally the Azure Integrated Hardware Security Module, which is our new in-house security chip that's built into every one of our new servers that's going live in Azure. So security is top priority for across the industry and for Microsoft. These key management services that centralized HSMs can provide are also provided through dedicated servers within the data center and hardware in that particular region. And then, of course, cryptographic operations on key management like generating, storing, and distributing are done through that centralized HSM. But as you think about scalability, the demand for these cryptographic operations grows. That centralized approach needs to scale. And so that's where those centralized HSMs can introduce a little bit of latency. So distributing this integrated HSM in every one of our servers allows us to really provide performance security. And that's where this integrated HSM comes into play as well. So the HSM strengthens key protection by enabling the use of encryption and signing keys while they remain within the bounds of an HSM and without incurring the typical network access latencies for attached like network HSMs. It's designed to meet some pretty stringent requirements of FIPS 143 Level 3 standards, which is one of the strongest security standards and offers great protection. We're deploying these servers in all of our new servers being deployed in Azure starting this year in 2025. And so this allows us to enhance the security for both our confidential virtual machines as well as general purpose virtual machines and containers. Diving in a little bit more here around this, how this integrated HSM works. One way you can think about it is it acts as an HSM cache. Like the figure here shows an HSM cloud service for key management. We'll have a confidential VM here and a TE or a trusted enclave here. And the keys are never checked out of the HSM. Instead, the central service, that in this case is run by Azure Key Vault, releases those keys to the integrated HSM. And in this way, the keys aren't exposed to the guest or host memory. They remain air-gapped from the hardware, from the CPU, and isolated from other workloads that might be running in that particular hardware as well. And so again, the benefit of doing this, as well as meeting that strong key protection standard, is also that we're able to accelerate in hardware this infrastructure service. So the next layer up, as we think about a zero trust architecture of these trusted enclaves, we have some granularity options here. Do we want to protect that entire virtual machine? Or do we want to just protect the container group or a container asset within that virtual machine? And so this helps protect the data that's in use in server memory by performing all those computations and that hardware base through this trusted execution environment. Now, all Azure trusted execution environments share this common zero trust architecture that you see here. It starts at the bottom of the stack with that hardware rooted trust that we just talked about. And then, of course, memory protection is enforced with the processor's memory management firmware and is inaccessible to Azure operators. So this helps ensure that only the software that is running within that trusted enclave memory can read and write to that memory itself. And this supports these zero trust principles of always verify and restricting access. Azure offers these TEs where the memory footprint or the size of the TE can be either the entire VM or a container group within the VM. And note that the container group isolation, which we sometimes call confidential containers, can help not just protect data in the TE from a cloud provider, but also insider threats as well. And that's really a key component of this TEE zero trust architecture. Now, through attestation, this helps us ensure that both the underlying hardware and the contents of that TEE are as expected before the secrets are released and the sensitive data is loaded into the TEE memory. And we've also enabled secure key release mechanisms to make sure that your data is only unlocked for processing within a TEE and never exposed outside of that secure environment. Then, of course, finally, everything outside of that trust boundary to the TEE, including the host operating system, the Azure hypervisor, the BIOS, the device drivers, they could be breached without threatening the data that's in that trusted enclave. And this supports the principle here of assume a breach in this zero trust architecture. Now, we're taking a full stack approach across this infrastructure. So container services, other PaaS, and SaaS applications can all benefit from this confidential computing approach. And we've got a very comprehensive set of confidential computing offerings in the public cloud. For the AMD stack, we use AMD SEV SNP at all layers of this stack. So beginning at the infrastructure layer, using our fourth generation AMD EPYC SEV SNP confidential VMs, they provide the ability to lift and shift, essentially migrate from on-premises into a confidential VM in Azure. Now, at the container layer, we offer confidential VM node pools through AKS, the Azure Kubernetes service, as well as our 3 container group isolation offerings, confidential containers on our Azure Container Instance, confidential containers on AKS, and of course, confidential containers on Red Hat OpenShift. Now, at the services layer, a new notable offering here is something called Azure Confidential Clean Rooms. And so this Azure Confidential Clean Rooms is a platform that allows multiple parties to share sensitive data while providing assurances that only trusted software that's running inside of that enclave can access that data. Now, that's computing servers. As we think about data servers in Azure, they're a little different. And so what we've actually been able to architect in Azure is really purpose-built specificity in our storage servers. So they are different from our CPU-driven servers. And one of the ways we do that is by introducing a new type of chip, which we call a DPU, or a data processing unit. This is designed for all of our data-centric workloads. So it's a high efficiency, low power, and high agility, and with higher reliability, and really supports our secure hyperscale environment. This is already being tested on our storage workloads, and what we're seeing is about 4 times the performance and about 3 times lower power usage. And so this is a pretty amazing thing for us on this storage optimization side as well. From a security side, what it does is it really reduces the attack surface. And so a DPU-powered server has a lot less components in it. It doesn't have PCIe switches. It doesn't have accelerator cards. It doesn't have NICs. It doesn't need a CPU. Essentially, this DPU is a fit-for-purpose ASIC that does all of that as well. Traditional storage server has all of those components, and you've got firmware, patches, attack surfaces that make up all of those. Whereas the DPU, it's integrated all those components into a single chip. And so the DPU is more efficient than traditional CPUs at processing these data-centric workloads, helps move the data, helps store the data, helps secure the data. And because it's a programmable ASIC, we're actually able to customize the data flow architecture and the storing service application stack that's running in Azure. So these are just some of the systems that help round out the hardware security layer in Azure as well. The HSM joins a portfolio of other hardware security investments we've made. And many of these we released through the Open Compute project. One of them, of course, Calyptra 2, which is an expanded capabilities for protection and recovery in addition to detection of breaches of root of trust. Adams Bridge is an open source cryptography accelerator designed for this quantum safe and quantum resilience. And so this is really critical as we think about this next wave of technologies and what's happening in the world. As we think about AI and all the scientific breakthroughs that are being made there, quantum computing is moving fast as well, both at Microsoft and across the industry. And so with all these new technologies, there's new risks with quantum computing as well, and particularly in the field of cryptography. And many of today's algorithms can easily be compromised with a quantum computer. So agencies like NIST have started requiring quantum resilience in these future systems. Adams Bridge will be made available as part of this Calyptra 2 standard, and it's an open source platform that is being shared back with the community. We're also working with the Open Compute project on a program called OCP SAFE. This program is an initiative that really outlines the systematic and consistent security audits that can be done on all levels of the hardware and firmware stack. And so combined with Calyptra, OCP SAFE helps make this very transparent and assurant hardware architecture that is shared and is common across the industry as well, helping make not just Microsoft's cloud, but the entire cloud industry much more secure and resilient. Of course, all this infrastructure at the hardware level is important, but it also needs to be battle tested. And that's where what we call the tip of the spear team comes in as well. This is our strategic unit made up of our threat intelligence teams, our red teams, and our hunt teams that are unified together. A couple of funny names here because, hey, they're security people. They got to have great names. Our Mystic team, really defines who our threats are. They're essentially the envisagers of all of this, what the threats are, what the code could be. Our red team then emulates these to see how prepared we are to defend against these types of attacks. And then our ghost team hunts for these threats and tries to disrupt these teams as well. So we kind of like to think of this a little bit like Voltron, right? Each of these brings this valuable and specialized set of skills. They kind of combine together, and that brings this very powerful force for battle testing all of this infrastructure and this system that we built. And these teams are all a core part of our CISO organization. And so this is a continuous innovation in our security strategy that's done across the products. And they directly influence our Secure Futures Initiative strategy and work directly with our senior leaders as well as our board. And so this is a different approach to thinking about how we're evolving, not just our security platform, but our operations, and then really tight collaboration between some of the most impactful functions of our security organization to really better understand, respond, and neutralize these threats that can emerge in our environment. So we've covered a lot of this hardware infrastructure and some of the security platforms that Microsoft put in place here as well. But how can we help you? There's a couple of programs that we have available to really help improve your security posture when it comes to operating in the cloud. The first two I'll talk about is Azure Innovate and Azure Migrate and Modernize. So these two offerings can support how you can accelerate your adoption of the cloud. Azure Innovate is designed to help you infuse these AI capabilities into Azure-based solutions and improve analytics to build really innovative projects on Azure. And then Azure Migrate and Modernize helps you take your current on-premises investments that have served you well for so long and securely and efficiently move them to Azure and help choose what part of those applications you want to modernize and take advantage of some of these cloud-native capabilities. So if you're ready to begin your journey on any of these capabilities, look at aka.ms/Azure Hero offerings. And then these two programs are backed by our Azure Essentials offerings, which are really our proven practices of how to elevate reliability, security, and performance considerations across your cloud and AI investments. It's like a one-stop shop to get a comprehensive set of resources, including tooling, skilling, guidance, reference architectures, and best practices as well. So the Azure Essentials Resource Kit includes all these capabilities, a lot of links to simplify some of our documentation and guidance. And you can check that out today at aka.ms/Azure Essentials. Coming up soon is the RSA Conference. That is one of our biggest industry security conferences of the year. And of course, Microsoft will be there from April 27th till May 1st. So if you're coming to that conference, scan this QR code or check out this link and hear from some of our Microsoft security team on the latest product innovations, get some insights into the latest threat trends that we're seeing, and help you understand all of the capabilities that we can help you bring to your own security portfolio. I hope you've enjoyed this discussion and got a peek inside the data center and at the security innovations at really that physical layer of the cloud. We do strive to follow a rigorous defense in depth and zero trust model of our architecture and our operations. And this is backed up by a really comprehensive auditing and compliance regime. Of course, security is a team sport. It's our top priority, and we hope you can take advantage of the tools and programs that I mentioned as well. So thank you very much, and I hope to see you at a future in-person event.